Hi, I'm John Paul Raj, and I'm on a mission to make the learning of math fun. So if you're new to this channel, please do consider subscribing. This is part 10 of transformations of functions, and on this video, we're going to talk about absolute value transformations. Let's start. When we discuss absolute value transformations, we're talking about two different kinds of transformations. One, which is a transformation of the range, and one which is a transformation of the domain, like every other transformation, right? So this is the absolute value of f of x. As you can see, the absolute value of f of x, okay, y is equal to absolute value of f of x, whereas this is the f of the absolute value of x. Can you see that? That's like absolute value of the domain, only the x values, all right? So here is the absolute value of the range, the y values, whereas here it's the absolute value of the x's, the input values, all right? So how does that affect the graph of the function? Well, you know, when only the y-axis are getting affected by the absolute value, which means none of the y values are going to be negative. So for instance, if the original function was some y is equal to f of x, original meaning the parent function, and let's just do some random sketch, okay? So the original function had some negative values and some positive values, okay, whatever that function was. What happens is that when we consider the transformation of this parent function and try to sketch y is equal to the absolute value of that parent function, which means what's going to happen is that the x's don't get changed, all right? It's not the x's, it's the y values. The y values become all positive. So basically what's going to happen is that these negative x values will remain negative, but it's corresponding, the corresponding y values, if they're negative, wherever the y values are negative, you just have to reflect that about the x-axis, right? X-axis. So the function, the graph of y equals absolute value of f of x would actually be something like this, all right? So the positive y values will remain as they are, okay? The negative y values, because they were here below the x-axis, they get transformed or reflected about the x-axis. So that's going to be, for this particular function, whatever this function is, if that was the graph, the negative y values are the ones that become positive. Their corresponding x values will still remain negative, but their y values are the one that has become positive. Oh, let me show that again. All right. The x values remain, the negative x values remain negative, but their corresponding y values get reflected about the x-axis. As such, you have both y values, meaning all y values are positive, and that's what this transformation is. So this is how we would sum it up for a transformation y is equal to absolute value of f of x, absolute value of f of x, you're going to reflect the negative y values, as we've done here, okay, about the x-axis. Whatever the graph is, okay, reflect the negative y values, the graph where it becomes negative, reflected about the x-axis. And once that is done, remember, as I said, the x values remain the same. You're just taking the absolute value of the y-axis. So if you take an example to illustrate this, if it were the graph of, let's say, x squared minus 3, all right? Now that's the parent quadratic function that has undergone a transformation, a vertical shift by 3 steps below. So you know the graph. Some of you have seen the video. For those of you who haven't seen the video of translations, please go ahead and take a look at this. This graph x squared minus 3 should have gone down 3 steps. So if that's negative 3 along the y-axis, the parent function has actually gone down. So that's going to be the function. Let's consider this as the original function, okay? The original function that we start with, okay? And these values where x is equal to 0, y is equal to 0 should be the positive root 3 and the negative root 3, okay? Now, suppose we want to consider the transformation of this graph and say, okay, we want to say the absolute value of this function, okay? So this is your original function that we start with, okay? F of x, and this is the transformation. We want to consider the graph, okay? What did we say? We are reflecting the negative y values about the x-axis. So that means this is where the graph is negative. These are the negative y values. That portion, only that portion gets reflected. Everything else remains. Okay, this is positive, this is positive. The graph, where is it negative? Just this part is negative. So we are going to flip it across over the x-axis. That's your x-axis, remember? So when you reflect that, you're going to get a graph something. So if that's negative 3, remember, it should flip. So there's positive 3. That means our graph should be, let me use another color for the flipped part. That's the graph. Okay, so literally it looks like, let me put it here. The flipped graph or the final graph for y is equal to the absolute value of x squared minus 3 should be a graph that looks like that's 3 and that's still a root 3 and that's still a negative root 3. Remember, the x values remain unchanged as we said, okay? The graph should be something like this. So that's the quadratic, and instead of going down, that part gets reflected and that part goes there. That is what this graph should look like. Okay, let's check it on our calculator. Shall we do that? All right, here we go. This is our graphing calculator, and I'm going to add a graph page, and I'm going to add the function. Let's compare the two. So first we are going to do an x squared minus 3, okay, and that's going to give me this graph, okay. So this is the graph, and we want to see its transformation, okay. Y is equal to absolute value of f of x. So just hit tab, and we're just going to get the absolute value template for that, and I'm just going to hit F1, okay. So it's going to give me y is equal to absolute value of that one. Here we go. Ready? Watch this. There we go, as we saw, and that is going to be 3, all right, and these are going to be the roots. That's going to be root of 3. The positive y values remain unchanged. It's the negative y values, the portion of the graph that is below the x-axis, that portion is reflected about the x-axis, and therefore the red graph has got all positive y values, and that is the transformation y is equal to absolute value of f of x, as we have graphed even without the aid of the graphing calculator. That's good. So now let's look at the second absolute value transformation, which is y is equal to f of the absolute value of x. Here, as I said before, it's the domain. Okay, the domain may have negative values, and where the domain has negative values, we are going to consider the positive values, almost like saying we're going to ignore the negative x values. Okay, so it's like saying for y is equal to f of absolute value of x, ignore the negative x values, and we're going to reflect the positive, because you're considering the positive, right? Reflecting the positive x values about the y-axis, okay? The positive x values remain, but the negative x values will take on the y values of the positive x values. So let's take an example. Y is equal to x cubed minus 3. And the reason we are choosing x cubed is because the cube of a negative number will still be negative, and we want to consider some negative x values in the mix also, as opposed to x square. You know, the square of a negative value will make it positive, and you will not actually be able to see visually the transformation of absolute value of x. All right, so yeah, that's why we're considering a cubic function here, and it's a transformed cubic function, meaning it's not the parent cubic function. It's gone down by 3 steps. So first, let's draw this graph. This is, let's say this is the x-axis and the y-axis, and it's gone down by 3 steps. So that's a -1, -2, and a -3. You are going to get a graph, something like that. Okay, that's going to be the graph y equals x cubed minus 3. Let's mark the important points. This the x-intercept is going to be the cube root of 3, all right? And the y-intercept is 0, -3. So it's that's the graph. And we want to consider what's going to happen to the graph of f of absolute value of x. That's more important, okay? That's what we are looking for. So the negative x values, as I said, the negative x values, we are just going to ignore. Negative x values. Remember what we said, ignore the negative x values. Just going to ignore, and even its range. So if you're ignoring the negative x values, it's as good as ignoring their y values also. Considering the positive x values in place of these ones and reflecting, it's almost like reflecting it about the y-axis. Okay, so considering the positive x values in the place of this one, and so that would be the graph. Okay, that would be the graph, and so this value out here will be the negative cube root of 3. Okay, so that's going to be the graph. This, let me just use another color both ways. Let me use red, or maybe this one. Okay, so that's going to be the transformed graph. Okay, so literally, as we said, the negative x values are going to be ignored, and so along with them, even their corresponding y values are going to be ignored, and we're just considering the positive x values and their y values reflected about the y-axis, and that is going to be the graph of y is equal to f of absolute value of x. Now let's check it on a graphing calculator, shall we? Here we go. I'm going to add a new graphing page. Okay, so here we go. I'm going to add a new page, and this time I'm going to call it x cubed What do we have? Minus 3, x cubed, sorry. That is not what we want. X cubed minus 3, and that's the graph, okay? That's the graph. As we saw, that's negative 3. And I want to get the graph of f, is it f5? All right, f5. And I'm going to use the absolute value there. Absolute value of x. And let's see what's going to happen, okay? Don't blink, guys. Oh, what just happened? Let me do it again. F5 of absolute value of x. And here we go. Moment of truth. There. Can you guys see this? Okay, it is a reflection. So as I said, the negative x values, it's almost like saying ignore them, and so their corresponding y values are also ignored, but it's only the positive x values that is being considered. And that's how we have to interpret the absolute value of the input. Okay, so you're considering only the positive x values and their corresponding y values, almost like saying it's a reflection of those y values about the y-axis, just as we saw in our sketch without the aid of the graphing calculator. So I hope that this video is useful to you in understanding absolute value transformations. I'm going to see you all in the next video.